Assembly modeling. As of now, we had discussed to create part model in SolidWorks, and we had seen a number of advanced modeling tools which help us the user to create more complicated shapes in SolidWorks in user-friendly way. And now let's see how we can create the complete mechanical system or the complete product in SolidWorks. As you know, the single system or the product cannot be created with the commands available in part environment, since you will not be able to dismantle it or you will not be able to explode it. So this assembly modeling environment will help us to create a model which represents different components where you will be able to manipulate as individual components, and also you can apply detail for each component according to your requirement. Assembly modeling will contain solid, sheet metal and surface model. It doesn't mean you want to create every assembly modeling with these components. It can be a combination of solid, or it can be a combination of sheet metal, or the combination of solid, sheet and surface. But assembly modeling can be done in 2, 3 or 4 different ways. Means you can assemble the model in top-down approach or bottom-up approach, or in a way where you can place all the components on a layout, and you can combine all this and you can retrieve some standard files and you can assemble this. This is all about doing assembly modeling in SolidWorks. Let us have the different approaches used in SolidWorks. Design method. Creating assembly using bottom-up design, top-down design, or combination of both methods. What exactly this bottom-up design? If the assembly is having totally 100 components and all the components you have the details, and now you want to exactly assemble this whole product, then you can go for bottom-up design. So what exactly this bottom-up design is doing? You create components separately and you conceive this part inside a SolidWorks assembly environment, and you will assemble it using mates. So when the parts detail are given elaborately and it is very clear, it is advisable to go with bottom-up design. And the next one is top-down design. Normally we create components using bottom-up design, but there are some conditions where you will not have the details of the product clearly when it is assembled or when you are going to create a new concept. That's why we need to go in top-down design. So what you'll do here? One, we will create first a layout sketch, and you will add material for it, and then you will convert the specific set of sketch into solid, and that solid will become one part model. Or you will do the complete assembly modeling. There are some situations where you need to locate one single hole on a specific component, and there you don't require to go to the other environment and do it, and there itself we can do it by using assembly features, and that we call as top-down design. And there are different combinations in doing this design method, and there are some situations where you will retrieve standard libraries like bolts, nuts, and that you will use to assemble the model. These are the various methods of doing assembly in SolidWorks. The next one, we should be able to understand how we can position the parts in the assembly environment. Mates. What exactly this mates will define? Mates create the geometric relationship between assembly components. The component has to be located on the surface or on the axis, or it should be located on the vertex or a datum point or a datum plane where you want to position this. as you've seen the relations defined in sketched environment. Similarly, we had to define the relationship between two components in an assembly. And once you start to assemble the components, the mates has to be properly defined between the components. And it is not essential for everyone to assemble the component with fully defined environment. Here you can see in this graphical user interface, you can see constraints, that is mates are shown in this feature manager tree. So the point what I'm insisting is, when you assemble two components using mating condition, you have to understand what is the degrees of freedom you require on that part. Accordingly, you need to use mate. You require the component to move linear or in rotation motion, you have to apply the relation in such a way, and you have to apply the mates in such a way the assembly should behave. And these are the various methods you will use in SolidWorks to assemble the components. And now let's see what are the things you will understand when you position the component, and which is most essential for everyone to understand how the component is placed, and how can I understand whether the component I placed in the environment, that is a graphical user interface of assembly modeling, whether it is grounded or fixed, or it is able to move freely, or it doesn't have any degrees of freedom. How can I understand this? And this slide will give you the option of understanding the prefix added to the component. In this image you can see the component is prefixed with F, which means it is fixed. And you can see one more component which is shown with the bracket of minus symbol. It means it is partially constrained, that is underdefined component. And you can see the various description given here. The first part in assembly is fixed. However, you can float it at any time. How can you float it? You right click on the component, you will get the option as float, and if you float it once again, you can make it as a fix by doing the same process. A fixed component has a F before its name, and floating component, that is underdefined component, has minus before its name. And if it is fully defined, it doesn't have any degrees of freedom, you will not have any prefix. And that's all about assembly modeling in SolidWorks. Let us have a small view on this, what we discussed in the fourth slide. The first slide indicates what is the meaning for assembly modeling. Here we have discussed about the assembly can be done using different components, and we had seen the design method, that is bottom up design or top down design, and we had seen how the mates and how to position the component using mates and what is the function of mate. And finally we had seen what is the prefix added for the component when you given any geometric relationship, that is applying mates, or you are going to fix in the ground. Now let's see the interesting one, that is applying mates for different components. In SolidWorks you have number of mates. Each mate is classified under three major topics. One is standard, advanced and mechanical mate. Let's discuss this in detail. As I told, in SolidWorks you have three types of mates: standard mates, advanced mate and then mechanical mates. Now we are going to discuss about standard mates, and these are the types available. We can apply coincident, parallel, perpendicular, tangent, concentric, log, distance and angle relations to the components. Now let's see what are the entities or the elements you can select for standard mates. It is applying coincident mate and concentric mate. For applying coincident mate, we can select circular edge, arc edge, coordinate system, line, point, plane, axis and face. In this example you can see here how the two components is given coincident condition. The next one is concentric mate. For concentric mate you can choose circular edge, axis, line and point. And here once again you can see two cylindrical faces are selected and concentric mate is applied. Now let's see how we can apply these two mates in SolidWorks. I'll go to SolidWorks environment, File, New, Assembly. Once the assembly environment is open, you can see the command is in process, it is begin assembly. This command can be once again retrieved by selecting the command called as insert components. We'll go to browse. From here I will choose the first component as bracket. And now when I place this component on this graphical user interface, now this component you can see it is given with the prefix as F. It means it is fixed. Now there is one more condition. I need to fix this component as per my requirement. What you can do is you right click here, go and say it should float. Now if you move this, you'll be able to move freely on the graphical user interface. To apply mates, you can choose this icon and go and say first one, that is front and front plane should be coincident, and top plane should be coincident, and right and right plane should be coincident. This is how you can apply mates, and you can position this exactly with respect to the origin. Or you can also select the origin of this component with the origin of the assembly. Both the ways we can do it. And let's see how we can retrieve the next component. To retrieve next component, you need to go to insert components, or you can choose from insert component. Here you have insert component, that is existing part and assembly. So there are two ways of retrieving the command. Another easiest way is select S shortcut at the keyboard and you'll be able to use the command insert. Go to browse. I will choose the yoke male part and click OK. Place it here. Now we need to apply the standard mates. Once again I will use this mate by using shortcut. My first condition is I should make it coincident, that is this face and this face should be coincident. And I can click right button on the mouse, and now I need to apply concentric mate. Go to concentric, select this face and this face, right click. Now you need to understand the degrees of freedom. If you drag this, you can understand the degrees of freedom available for this component. Click OK here. Once again I need to retrieve other component. I will go to insert component, browse. I will take the spider part, I will locate here. Let's see how we can assemble this. Go to mate, choose this face and this face should be coincident, right click, and once again this face and this face should be coincident, right click. And now we need to make concentric between two circular holes, this hole and this hole. Yes, we have assembled this. The next condition is I need to assemble one more component, that is the yoke female part. Go to insert component, browse, go and choose female part, click open, place it here. And once again applying the relationship, here we need to place this component on this face, but I don't require exactly to be coincident. First thing I will do is let us make this and this hole to be concentric, and let's rotate this and we will see how we can locate this. But you can see it is not able to properly position this. So what I will do here is I will say coincident, that is this face should coincident with this face. And now if I rotate this, you can see it is locked on this component. And now I want to exactly locate this on this face. I'll go and say parallel, this face and this face should be parallel. Yes, we have located this. So now we have seen how we can use coincident and parallel constraint in SolidWorks. And that's all about applying coincident and concentric constraint in SolidWorks. Let us discuss the remaining commands in the next slide. The next standard mates are parallel and perpendicular. The references that you can select for applying these relations are axis, face, line and plane. And these two images will give you an idea how this parallel constraint is applied and the behavior of the component. And here you can see there is one more linkage assembly where you can see the perpendicular mate is applied between the axis and the face. Let's see how we can do this in SolidWorks. In this connecting rod assembly, we are going to see the assembly of this component with this one and this component with this rotating wheel, and we are going to assemble this connector parallel to this line segment. Let's see how we can do this. I will go to mate and I will say first one is concentric between this surface and this surface, and once again concentric between this surface and this surface. Now we have the option of applying this. Before that you can see it is rotating in this degrees of freedom once this concentric is applied. Now what I need to do is, I don't require it for this constraint also, I need to apply parallel constraint between these components. So first what I will do is, I will go and say this axis, that is the axis I need to first enlight from here, temporary axis, okay, it is visible, and I would like to say parallel this and this should be parallel. And after that what I will do is, I will say once again concentric this in this face, and once again I will say this and this face should be concentric. And once we applied this, you can see the parallel mate applied to this connector so that it will accommodate exactly, and right now you can see it has parallel relationship with the sketch drawn in assembly modeling. This is how you can apply parallel mate and concentric mate for this connecting rod assembly. And now let's see one more example for perpendicular mate. In this linkage assembly, for this component you can see it is able to move in this direction, but I need to assemble exactly perpendicular to this face. So what are the entities you can select for this perpendicular mate? Go to mate, select this face and this axis. Now what I need to do is, you need to select this perpendicular. Now you can see the axis will be perpendicular to this face. And this is how you can apply perpendicular and parallel mate between two components by selecting the face, line and also axis for applying these mates. The next mate under standard mate is tangent. Tangent mate is used for aligning two cylindrical faces or a cylindrical face on a planar face. And this image will give you an idea how these two components are aligned. Let's see how we can do this in SolidWorks. We have two components. I need to exactly align this shaft on this face, but it should be tangentially aligned. Now what I need to do is, I will go for mate. Here I will go for tangent, this surface and this surface. Now you can see it is tangentially aligned. And you can just move this and you can understand how this is tangentially aligned. And that's all about tangent mate. Tangent mate can be given to either between two cylindrical faces, or you can also give tangent between this surface and this vertical face. What I will do is, I'll go to mate, tangent mate, this surface and this surface. This way also we can give it. It is one is cylindrical face and one is another cylindrical face, or you can select planar face and cylindrical face. The next topic is lock and distant mate. Lock and distance mate, once again it's a one more standard mate where you will apply distance between two components. We call it as a distance mate. And if you want to position and orient the two components, that is, you want to maintain the relation, you can apply lock. Let's see how we can do this in SolidWorks. I'll go to the over-render component. Here let's see how we can this is a machine which is used for automatic movement of the machine. We have here a motor and there are different actuators. Let's see how this component is locked, and so that these two components can move in the same direction when you apply mate or when you drag it manually. Now if I move this component, you can see this component and this component is moving separately, it is independently. Now what I will do is, first I will apply constraint between this face and this face, and I will also drag this and I'll keep it here. Rough distance I will give it here. And now if I move this component and this component should move without any orientation. That is, if I move this, it should move as a whole unit. I'll go to mate. Here I will use lock. This component and this component I need to lock. And once you applied lock, and now if you move it, you can see it will move as a single unit. And moreover, when you apply mate between these two faces, you can see it will move as a single unit. This is what we call as lock. We are fixing two components like bolt and nut, washer, bolt and nut. And there are different type of couplings where you can make 2 or 3 components to be locked, so that you can move all the component as a one single unit. Now let's see the other example in this assembly, distance mate. First thing is, I would like to assemble these parts. This is one more support part for an assembly. I would like to apply mates here. This face and this face should be aligned, and but this face and this face aligned. Okay, it is not aligned properly. I'll go and say delete. Now I will do once again mate. Here I will use coincident, this surface and this surface, and I would like to say this and this should be concentric, and this two if I make concentric. Now you can see these two are concentric, and once again I need to do this surface and this surface, both are concentric. And after this, I would like to make these components all to be concentric. What I will do is this and this. Before that, I will undo this and I will say this component, that is washer, that is spacer, we used to say, this and this has to be coincident, and after this, this component, surface, and this should be concentric. And now I will do this. Right now this component and this component has to be concentric, and now we will apply distance mate between these faces. I'll go to distance, this face, and now the inside face. That is, we have to select this face, and now distance I can apply here and click OK. This is how you can apply distance mate. And in this tutorial we had seen applying concentric, coincident, distance mate. And as a whole, you need to understand, when you need to apply lock, definitely those components will be fixed in their position and orientation. So it is easy for us to move two components as a single unit. And tangent mate, once again you can use cylindrical face to be lying on the planar face or another cylindrical face. It's all about standard mates available in SolidWorks. Now we need to discuss one more mate. Let's see in the next slide. Angle mate. Angle mate is used to give a geometric relation between two faces by giving angular dimension. Let's see how we can do this in SolidWorks. These are the components which we are going to try to create an universal joint. I have three components. I'll start to do it. First, this component is fixed. Now I want to align the shaft. I'll go to Mate, select this face and this face, and I have to flip the direction, and done. And what I will do is this and this face should be concentric, and this face and this face I'll apply, and these two faces should be coincident. And once I complete this, I need similar kind of component on the other side. So I will use Control key and I'll make two components now. Let us assemble this joint. I will say this and this should be concentric, and rotate and keep this side, and I will say this surface and this surface should be coincident. And now this surface and this vertical surface, and I need to make aligned, and once it become aligned, this should be given concentric. So once we complete this, at last I need to make an angular constraint. That is, I need to use this universal joint for transmitting the angular motion. For this, once again go to Mate. Here we have Angular Mate. Select this face and this face. Now the degree given here is 30 degree, and click OK here. Now you can see the face is aligned at an angle of 30 degree. This is how you can apply Angle Mate in SolidWorks. The next command in SolidWorks is Advanced Mate. To assemble the components in an easier way and in a better way, still we have more mates in SolidWorks, that is Advanced Mates. Symmetric, Width, Path Mate, Linear Coupler, Limit Mate, which is giving a linear constraint and also angular constraint. This constraint will help the user to assemble the components in the easiest way, so that the component will be exactly positioned and it will have a proper geometric relationship between the components in the assembly. And now let's see about Symmetric Mate. Symmetric Mate faces two similar entities to be symmetric about a planar face of a component or a plane of this assembly. In this image you can see there is a plane, and I had selected phase 1 and phase 2, and now if I drag one screw, the other screw will also move in the opposite direction. And the references that we can select for this symmetric mates are vertices or sketch points, edges, axes, sketch lines, planar faces, spheres of equal radii, cylinders of equal radii. Let's see how we can do this in SolidWorks. Now this component is fixed. I will float this component, and I need to exactly locate on the assembly plane. Go to Mate. Here I will choose this front plane of frame, and front plane of assembly should coincide, and top plane and right plane. Once I do this, now my next job is I want to assemble this screw, and I need to do one more thing. This plane, that is screw plane, top plane has to be parallel with this face. Yes. And after doing this, I can drag and I can check the relationship of the screw with this clamp. And I need one more component. I will drag and I will say I need to assemble on this side, and distance has to be flipped. And once it is flipped, the next condition is we need to say the datum plane should be parallel to the face. That is the screw's datum plane. That is here I'll open top plane, and this plane should be parallel the surface. And once I complete this, now you can see the application of Symmetry Mate. Symmetry Mate, I'll choose the plane as right plane, and the surface, this surface and this surface. Now you can see once it is applied, you can see immediate movement of the component. Now if I drag one screw on the other side, the other screw will also move on the opposite direction. And this is all about doing symmetry mate in SolidWorks. Using width mate, you can position a component by selecting the two planar faces or two planar faces and one cylindrical face. So this will center exactly between these two vertical faces. And apart from that, you can also select two slanting faces so that you can position exactly in the middle. This is one picture representation of the example to understand the width mate. If it is applied, the possible references we can select. Groove width reference, under this you can select these combination, and under tab reference you can select these combinations. Let us see how this car jack support is assembled on this two link, not on this, between two links in the SolidWorks environment. This is the car jack assembly. Now I want to position this support exactly between these two links. So what I will do is, as usual, I will go to mate. Here we will choose advanced mate. Under we have width mate. Under width selection, this is what I was mentioning here. Width mate, what are the references? Under width reference, what are the references you can select? And under tab, what are the references you can select? Now I'll go under width selection and I'll select these two faces. And under tab selection, I'll select these two faces. So now you can see the support will exactly position in between these two links. And later, once again, you need to choose other constraints like symmetric or coincident or concentric, which can position this component. Okay, and this is how we can position this using width mate. This is one example, and I'll give you one more example also. Here you can see there are two components. These are two machine components, and I need to assemble exactly this component in mid of this. But if you see, I don't have exact measurement of these two components, but I would like to exactly position this so that it will be positioned exactly in the middle of this. So for this, what I'm going to do is I'm going to use width mate, and under this I need to choose advanced mate, width mate, and here I will choose these two surface should exactly position these two faces. Now once again I will say these two faces, I need to go with mate. These two faces should exactly coincide these two faces. Now I will just drag this and I'll show you how this is positioned. You can see here the position of two components exactly centering between the two faces. This is how we can use advanced mate to position the component exactly between two faces without using repeated number of mates to position the component. This is all about width mate. Path mate. A path mate contains a selected point on a component to a path. So what exactly we are doing here? In this image you can see this block should travel along this conveyor, along this path. So what are the entities we will select for this path mate? We will select a vertex or a datum point and we will give a path. So this point will exactly travel along the given path. Let's see how we can do this in SolidWorks. Go to SolidWorks graphical user interface. In this component, first I need to locate on this face. I'll go and say mate, coincident, this face, not point, this face, and okay, I'll go and say this face and this face, and I will locate it roughly over this face. Now we need to apply path mate, and I will say this point here we need to select component vertex. This is my component vertex, and the path is, this is my path. Now you can see you'll be able to move in this direction, but now you can see it is rotating in all the direction, but I need to move only in the specific direction. When I drag this, I need to move only in specific direction. How we can do this? Here you will have number of parameters to control this orientation. We have free path, distance along the path. You can enter distance how much you need. Accordingly, if you drag, it will be incremented in this distance. And you can apply once again percent along path, and now I will use free right now. And once again you can see here how it should move. It should move freely or it should move along the path. How it should move. So when you select follow path, you will have the option of defining X direction, Y direction and Z direction. And here we have once again free and up vector. Here you need to define the vector so that the component will be rolled based on the vector direction. And once you finish all this, you can define the path mate and click OK here. Now I had given for the path constraint free, pitch also free, and also it should roll freely. I click OK here. Now I need to select one more constraint. This vertex should be aligned on this path. And once you complete this, now if you drag this, you'll be able to understand the behavior of this component. Drag this, you can see the element is moving along this path. This is how you can define the path mate for the component which is moving along the path. And that's all about path mate. The next advanced mate is linear coupler. This mate establishes a relationship between the translation of one component and the translation of another component. In this image you can see edge on the first bottom component is selected and edge on the overlying component is selected. This is an aluminum plate which is used in the drawers. Let's see how it will work out. Now we had assembled this is the fixed part, and this can move inside and this can also move inside. Now my intention is, if I move this to 1 mm, this should move 2 mm inside. Let's see how we can do this. Go to mate, and from here we need to choose advanced mate, linear coupler, ratio 1:1. I'll make it as 2, and now I'll go and say which edge you want to do it. I'll select this edge and this edge. Once you selected, now we had given the ratio 1:2. I'll click OK, and now if I drag this, you can see here if I move this as 1 mm, the upper component is moving 2 mm. This is how we can give relation between two components in a linear dimension. And that is what it is explained here. A mate establishes a relationship between the translation of one component with the other component. Next, limit mate. Using this advanced limit mate, you will allow the components to move within a range of values for distance and also for angle. You can either a starting distance or a starting angle, and you will define the maximum distance, that is maximum value and minimum value. And these two images you can see the example for limit mate. This is defining distance limit mate, and this is defining angular limit mate. Let's see how we can do this in SolidWorks. First I will insert the base component. I will go to the hands-on folder. I will take the base part. I'll keep it over here, and next component I would like to retrieve. Browse second component, click OK, and here once you open this, now you would like to position this, so this and this should be concentric. Now this can move to and fro, but when it is in the motion, what my intention is it should not hit this surface, but it should maintain the distance of 3 mm from this surface. That is, this end should stop 3 mm before this face. For this we need to go to advanced mate. Here you choose distance mate, that is distance limit mate. Select the two faces, this face and this face. And now the default value 1 is defined here. This will define the distance as of now, how it should position. I need this to be positioned 5 mm from this face. The maximum it can go to 30 and minimum it can go to 2 mm, and give done here. Once you complete this, you drag this component. You can see beyond this point you cannot move outside, and when you move inside you cannot move beyond this 2 mm clearance. This is how you can define limit mate in linear direction. Now there is one more advantage we have here, that is angular mate. Limit mate, in that we have angular mate. I will go and retry one more component here. Limit mate angle, first component and second component. I place the two components on the screen. As you know, the first component will be fixed. Now we will try to assemble this. I would like to apply mate between this and this should be concentric, and I'll rotate and I'll see how it should be fixed. Okay, now I'll make this surface should mate on this surface. Once I complete this, now let's put in one direction so that selection will be easy for us. Now let's see that angle orientation given here. It is rotating in this way. Now I want to apply the limit mate for this component. Let's see how we can do this. Go to advanced mate. Here we have angle, and we need to select two faces, and the angle 30 degree right now you can see it is applied now. And when I change this 30 as 45, you can see the reflection on this component. And I'll make maximum angle to be 90 and minimum angle should be 0. Once I complete this, I'll click OK here. Now you go and drag this component. You can see the difference. I'll drag this component up to 90 and I can go up to 0 degree. This is how you can define limit mate in terms of distance and in terms of angle. The next interesting mates are mechanical mates. Cam, hinge, gear, rack pinion, screw, universal joint. Let us see each mates in detail now. First one is cam mate. What exactly this cam follower mate will do? This is a type of tangent or coincident mate, I can say. And here you will define the two faces where you want to apply the cam follower mate. You can make the profile of the cam from line, arcs and spline as long as they are tangent and form a closed loop, and that can be used as a follower. Otherwise, if you use non-tangent line segments, definitely you cannot use for this cam follower mate. Let's see how we can apply this in SolidWorks. Here I have three components. One is fixed and other three are free to move. Now I want to apply the cam follower mate for these two components. First I will do this and this surface. This surface and this surface should be concentric, and this surface should be coincident. And now you can rotate this. We have the degrees of freedom on this rotation axis. And the next one is coincident this axis with the assembly plane. I will take this assembly plane. After this, I would like to say I will drag this downwards, and once again I will say this axis should be parallel to this plane. And once I complete this, I would like to say this face and this face should be coincident. And now at last I would like to go and apply mechanical mates. It is cam, select the face. One is entities to mate and cam follower. I will use entities to mate and I'll select these faces. And once I complete this, I'll go and say cam follower this and click OK here. And now if I go and drag this, you can see here the follower is exactly mating with the cam. This is how you can create cam follower mate in SolidWorks. The next mechanical mate is hinge. A hinge mate limits the movement between two components to 1 rotational degrees of freedom. These two images will give you a clear idea how it is given for the two components. Here you can see a plate. This is a holding stand, and this is a plate, and the hinge mate is applied by using these cylindrical faces, and this violet face is used for coinciding the two faces to be same on the plane, and these two faces are used for limiting the angle, rotational angle. And in this car jack assembly, this link is matched with this component by using hinge mate. Let's see how we can do this in SolidWorks. This is the car jack, and now I need to assemble this component. This is a side support block. I'll go to mate. Here we have mechanical mate, hinge. Hinge you can define, one is concentric. I'll set define concentric, and next we have to input two surfaces. And now you can see we have completed this. Similarly, you can see the components which is given here. All the components are mated using hinge mate. So for these type of assembly, hinge mate is exactly reducing the number of steps involved in defining the mates. Imagine if you don't have hinge mate, what else you will do it? Definitely you will go for first concentric and then coincident, and you have to define number of faces for the reference and finally get it. And this is how you can see SolidWorks is user friendly in positioning the components for an assembly. And next, one more example, let's see. This is one more hinge. I would like to give hinge mate for this component. Hinge, I will select this surface and this surface, and this bottom surface and this bottom surface should be coincident. And after that we need to give angular limit. I'll go to specify angle limit. You can select these two faces, and for this you can give the angle. I need this angle to be 45, and how much you need you can give it here. Here it is not possible to enter negative value. I need to enter positive value, and once you complete this, you can define the maximum and minimum angle it can rotate. What is the maximum angle and what is the minimum angle? Minimum angle is 30, maximum angle is 90, and here it is 90. Not possible. Once again I will do it. This should be as the angle should be 120, and I'll make it as 30. Sorry, I'm just reversing the enter the value. I'll make it this to be 120 and this to be 30, and click OK. And now I'll go and rotate this. Now you can see the difference here. Cancel this, rotate this. Now you can see we can rotate up to this angle, that is 30 to 120 degree. And that's all about hinge mate and SolidWorks. Gear mate, the interesting one, mechanical mate. Gear mate forces two components to rotate relative to one another about selected axis. Here you can select two axes or two surfaces, that is cylindrical surfaces. Let's see how we can do this in SolidWorks. I have spur gear 1 and spur gear 2. Both has same module and number of teeth, everything is same. First thing is the initial one we need to position. We go to mate. These two gears should rotate. So what I will do, I will retrieve the display of temporary axis, and I will say this axis should be coincident with this plane. Same like this axis should coincide with this top plane, and this axis should be coincident with this plane. So we defined axis should be coincident with the front, top, and this flat surface should be with the right plane. And the next we need to say this surface and this surface should coincident, and after that this plane should coincide with this plane. Yes, and now it is able to rotate here, and now I will locate this roughly near to this spur gear so that it will be easy for us to adjust this, not this one, this spur gear. And once we place this, we'll click OK here, and now let's see how the relationship will be applied. I'll go and say mate. Here I will say mechanical mate, gear. Here we need to select axis or two faces. Select this, you can see automatically the ratio is assumed here. Click OK here, and once you complete this, now if you drag one spur gear, you can see the other gear will also rotate. And this is how you can give gear mate to the components. And similarly, we can also give a physical motion for this component. What you need to do is, you need to go for basic motion. Here we have servo motor. Select this face. We need to use rotary, correct? And here I will use this axis, and this is my model, not required. It is enough to define only this axis, and speed is 100 rpm. Click OK. Now you can see it is rotated. Now I will calculate, and once you calculated this, you can go and play and you can just see how it works. I will stop this, I will reduce the speed, and I'll play this. Now it has increased. I will go and decrease the speed, and I'll play this right now. You can see the basic physical motion given to this gear mate, and this is about gear mate. Under mechanical mate, we have rack pinion mate. Using this rack pinion mate, it will help us to assemble a rack pinion assembly, that is a mechanical system, which will help us to cause the linear translation of one component based on the circle rotation of the another component, and vice versa. And there is no condition that we need to have a gear teeth on the component. Let's see how we can achieve this in SolidWorks environment. Here, this is an basic mechanical system which is operated by hand, and here if I rotate this pinion gear, this rack should go in linear direction, that is, it should go in this direction, which will help us to do any basic operation like chamfering on a hole, or pressing any component, or doing drilling operation, etc. It may be anything. So now I want to apply the condition for this between these two components. So what I will do is, I'll go to mate. Here under mechanical mate, I have rack and pinion. Now we need to select the rack edge, and pinion I will select this edge. So now we have applied the condition, and click OK here. Now if I move this component, you can see here when I rotate this rack and pinion, when I rotate this pinion gear, you can see the rack will also translate. This is called as rack and pinion mate. So this will help us to exactly simulate the mechanical system available in the almost all the machineries. That's all about rack and pinion mate. Universal joint. In universal joint, the rotation of one component about its axis is driven by the rotation of another component, that is the input shaft and the output shaft about its axis. Here you can see in this image, input shaft cylindrical face is selected and output shaft cylindrical face is selected to apply universal joint. And when you rotate this shaft, you can see this shaft will also get rotated. Let's see how we can apply this in SolidWorks. Now this component is assembled and this is a universal joint. If I rotate this shaft, you can see how this component rotates. Here we don't have any universal joint, we have normal standard mates like concentric and then advanced mate like width, and we assembled it. Now I will go and apply mate advanced. Here I have mechanical mate, under we have universal joint, and I will select this first face as the input and second face as this point, and now I'll click OK here. And now you try to rotate this one shaft, you can see the other component will also get rotated. This is all about applying universal joint between two shafts, one is input and one is output. And the next one is screw mate. A screw mate constrains two components to be concentric and also add as a pitch relation between the rotation of one component and the translation of the other. In this model, in this assembly, you can see if you rotate this handle, this jaw, that is movable jaw, will move. This is a machine wise. Let's see how we can do this in SolidWorks. I'll go to my project. Here I have the component. Now my first intention is to apply the mates to position this component on this hole. I'll go to mate. Using standard mates, I will say this and this concentric, and this surface should exactly lie on this face. And once I complete this, my next intention is this component should be, you can see this component is moving beyond the limit, so I will limit and then I will apply the screw mate. I'll go to advanced mate. Here we have limit mate, and we can select two faces, first face and second face, and now we can see here the distance between these two, the minimum, that is the defined distance I required here 60, and I will make it as maximum distance to be 110 and the minimum distance to be 5 mm. I'll make it as this 110 to be 90 and click OK. Now when you drag this component, you can see it goes up to 90, beyond that it cannot move, and if you go close near to this, it will stop having this clearance of 5 mm what we defined in this limit mate. Now I'm going to apply a screw mate between this movable jaw and this handle. Let us go to the mate. Here we have mechanical mate, screw mate, and I will select this revolving surface, and I need to select the other inside face. Right click here, select other, and I will choose the movable face, and here we need to say distance per revolution is 1 mm. I'll click OK here, and now if you drag this wise or if you rotate this handle, you can see the movement of movable jaw. And this is how you can apply screw mate between two components. Let us see one more example. Screw jack. When you rotate the handle, you can see the height of the jack is increased. It will uplift the weight kept on the support. Here I have the spindle. Now you can see it is not actually moving upward direction when I rotate this. Now I need to apply the relation between screw mate, relation between two components by using screw mate. We'll go to mate. Here I have screw mate, and I'll select this face and this inside face. Right click and I'll say select other, inside face, and distance per revolution 1 mm. I'll click OK here. And once I finished, now you go and rotate, you can see the difference here. Now I'll rotate once again. I can see, otherwise I will drag this downwards, you can see the rotation of the spline. That is rotation of the spindle, threaded spindle handle we can say. This is how we can apply screw mate. Still you can define the screw mate distance. This has 5 mm, and now if you rotate, definitely you will be able to see the difference. You can also change the direction, which direction you want to move. And this is all about defining 3 type of mates in SolidWorks. That is standard mate, advanced mate, the last one we had seen, the mechanical mate. I'm sure using all these 3 types of mates, definitely any user can position the product in any complex geometry or any surface to position exactly and to understand the relationship between 2 components. And in assembly modeling, it is very important to understand the constraints, that is mates, because once you decide to understand the behavior of the machine, it is directly depending upon the mates you had applied. If you apply screw mate, as of now you had seen, we apply screw mate. So if you give a drive, give a rotation to one spindle, and you can see the upward, that the jack is moved in the upward direction, it is lifted. Now similarly, you need to understand how different mates can be given. And the last mate also we had seen, it is in this mission wise, we had seen the application of limit mate. So the application of mate is very essential for everyone to understand exactly how it behaves, so that you can avoid the confusion in understanding the behavior of the whole assembly. And the next topic we are going to see in assembly is smart mates. Let's see how we can do this in SolidWorks. Smart mates. Smart mates functionality will help the user to apply mates without much of effort, and without opening the mate property manager you can apply the mates. The only thing you need to do is, when you are dragging the component, you have to press the Alt key and drag the face of one component onto the face of another. Let's see how we can do this in SolidWorks. And here you can see rear tire, sitting rim and wheel. And now I'm going to assemble this wheel into sitting rim. Let's see how we can do this. I'll go to mate. Here mate, you have one more option called as multiple mate mode. If I select this, I can do first, second and third. 3 components will be aligned in one axis, and this is what we call as multiple mate mode. And this is helpful definitely when you are doing assembly where all the components should be on the same axis. And now let's see about smart mates. Now what I will do is, I will use Alt key and I will drag this bolt on this cylindrical face. Now you can see it will give you an option of applying concentric mate. And once you leave the Alt key, you will be able to get this dialog box where you will be able to apply perpendicular, parallel, tangent, concentric, angular, distance, whatever you need you can apply here. And once you finish this, click OK here. And this is how you can apply smart mates in assembly modeling of SolidWorks. The next smart mate is, we are going to drag a component from one window to another, and we are going to apply the mates. And in this window you can see this is a switch and this is a flashlight, and it is dragged, and you can see here constraint is applied, this mate condition is applied, it is showing. Let's see how we can do this here. I will drag this component. You can see here this is the switch. I need to drag like this, and if you place it here, you can see once again the mates are displayed, and just leave here. You can see the mates will be highlighted here. You can choose parallel, perpendicular, angular, which one you need you can apply here. And once you have done this, click OK, and the remaining constraints you can apply. This is how you can apply smart mates by dragging the component from one window to another window based on the face. The next smart mate is mate reference. We will define the reference for the part in the part modeling environment, and when you drag those parts into assembly environment, it will be assembled based on the mate reference given in the part environment. And now we are going to assemble a plate on the gearbox housing. Let's see how we can do this in SolidWorks. This is now part, and we are in the part modeling environment. To define mate reference, you need to go to reference geometry, mate, and here the first one is primary reference is this way, and this should be as a default coincident, and it should be aligned, that is, it should be anti-aligned. It should look in opposite direction. And the second reference is this, and this is of once again coincident, and this should be aligned. The third reference is this face, and I need this to be once again coincident, and this should be aligned. And click OK here. Now we have defined the mate reference for first component. Save this and close. Now we will go and open the second component, that is cover plate. And now we need to define the same mate reference here where you want to locate the other component. I'll go to mate reference. Here I will choose once again this as the primary, and here I will say coincident and anti-aligned. And second reference is this, and this should be coincident, and this should be aligned. And the third, that is tertiary reference is this, and here I will say coincident, and this is aligned. Once you completed all this, click OK here and save this. Now what you can do is close this and go to the new assembly file, and here I will retrieve the first housing component and locate in this graphical user interface, and second component cover plate, and click OK. Now you'll be able to see it is automatically snapped to the mate references, and once you click here OK, and now you'll be able to see the object is exactly located on the housing body. This is how we can define mate reference, and using that mate reference you can assemble the components. And this is what we are saying here as smart mate. So there is no need of defining the mate conditions in the assembly. Instead of that, we are defining the mate reference in the part itself. As you know, standard parts like bolt, nut, washers, you know that always the mate reference for the cylindrical face will be coincident. So that if you defined, and you can use it anywhere so that you can avoid the time required in doing it. This is how you can use smart mate by using mate reference. The next smart mate is using the holes available on the circular pattern. We are going to align those circular pattern on the other components pattern, and this type of approach will help us in avoiding the multiple tasks. Let's see how we can do this. Here this is assembly environment, and this is part environment. Now I need to align this flange on this face. What you can do is you select this edge and drag this over this face. You'll be able to get this icon and leave it here, and now you see the holes are aligned exactly based on the pattern, and you can see automatically 3 mates will be created for this assembly. And this is what all about applying smart mates in SolidWorks. So these approaches will definitely make the user to interactively work with the software even in the assembly modeling also. Now let us see how we can manipulate components in an assembly. One, we are going to see how we can replace the existing component, and we are going to see how we can move and we can rotate a component using triad and also using specific tool. Let's see how we can do this in SolidWorks. This is the assembly of a front wheel, and now I need to replace this disc with another disc having number of holes in more in the circular pattern. Now I need to replace this component. For this you need to right click on this front brake disc and expand this, go to replace components, and from here you can see there is an option called as match name. Manually select use match name and go for browse, and I will use right now front brake disc 022. Open this, and now I will click OK. This one I don't require. This is the one I require. This okay. Then after this I will click OK. Now you can see the brake disc is exactly replaced with this front brake disc 022. If you need, you can flip mate alignment. If required, you can select the face and you can do it. And you can also see the preview if you're not placed it properly, or if you are applying the mate once again for this disc. You can see here the mates which is defined for the previous disc, the same right now it is copied by the replaced component. So it is duplicating once again what we did for the first disc and thereby reducing the time required to manipulate this component. And that's all about replacing the component. Now let's see how we can rotate, move a component in an assembly. Here this part I need to move to and fro. You can use this way, or if you want to move in a specific direction XYZ, you can also use move with triad. Right click, go with move with triad, and here you can see triad. You can use this triad and you will also have this deviation scale, and you can also, if this component is having the degrees to move on the upward direction, we can use that. This is one way of doing it. Now what I will do, I will go and say all the constraints and remove it. Now right click here, go and say move with triad. Now you can see we can move in up direction, and you can also move in rotational way. And apart from this, if you want to move the component, you can use from here move component, and once you go for move component, here you have smart mates. It is when you are moving itself, you can apply mates if required by using the drag alt plus dragging the left mouse button. Now I don't use the smart mate. Now I'll go and say free drag. If you don't require, you can use along assembly XYZ, or you can choose along entity, and I can select one entity, and along this I can move this. Or otherwise you can say by delta XYZ, you can enter the value 20 in delta X, enter 20 and apply this, and to XYZ position it is measured exactly with 0, 0. This is how you can manipulate the components in SolidWorks environment when you are doing assembly modeling. Since manipulating is very important, the user should understand how the component can be moved easily inside assembly modeling environment, because when any assembly is finished and you need to move the component manually from one location to other location, you need to understand how the component can be moved, and if you require the component to be moved in a precision location, then this tool should be known by the user. And that's all about manipulating the component. In the next slide, you're going to see the same command, move component and rotate component, but we are going to understand the collision reduction, dynamic clearance, and deducting interference. Now we are going to find out the collision reduction between the components, and we are going to understand the clearance when you are moving the component dynamically, and we are going to find out the interference between the components. Now this is the holding, this is the clamp hold assembly. Now we are going to find out the collision detection. Now what I will do, I will make this component to collide, or I will move like this manually, and now I need to find out the collision between the components. You go to evaluate, and here you have interference detection. You can select this interference detection, and here if you select clear calculate, you will be able to find out the interference. But here there is no interference, so we don't have any issue here. And let us make a mistake. It is, I will make a collision here. Now I will go and say interference reduction, and now I calculate this. Now you can see there are two interference. One is showing these two link arm, and also there is one more interference between these two portion. So now you will be able to understand how to find out the collision between two components. And moreover, when you are creating this, you have more control on this. You can treat the coincidence and interference, and if you use calculate, it will show all the coincident phases. The advantage of using this is when you are doing the simulation, that is when you are doing any validation, you want to apply contact between all the phases in the assembly. You can use this treatment coincidence as interference, and you can find out where are the phases, and that phases can be used for the contact between the two phases, and we can apply the contact condition. Like this, we have number of options available here, and you can define the display of this part, whether you want to see in hidden, transparent, or use current, and click OK here. This is how you can find out collision detection in an assembly. Now next example, let's see how we can find out the dynamic clearance. I'll go to the spark plug assembly. I will use the command move component, and now I will select this component to move from this area to this area, but I doesn't know what is the distance between this and this. I need to exactly understand, I need to exactly locate when I am nearing to the distance of 3 mm from this surface. For this, what you can do is go to collision detection, and now let's see what are the different options available here. Collision detection, I'm going here and I'm saying drag this, and here you can see stop at collision. I will use one more option called as sound. Means if you hit this part other component, it will make you noise. It will give you a warning sound. If you don't require, you can uncheck this, and this is highlighting faces. If you deselect this, you will not be able to see the faces, but when you select this, you will be able to notice here. And apart from this, you have here option called as stop at collision. You can uncheck this, and when you move this, you can see it will not be able to show this, but still you can show the collision using sound. When you hit this, you can see the sound will be produced. And now I'll go and say stop at collision, and now I'll drag this, and I'll be able to see. Now my next intention is understanding the clearance. Go to dynamic clearance, and this is my component. The next component is this. Two components we have selected, and here distances I'll make it as 2 mm, and now I'll go to resume drag, and now I'll go and move to this position. Now you can see here it is 1.2, 1.3, 1.4. Beyond 2, you can see it is showing the measurement here, and when I'm just nearing to this 2 mm, and you can see here just going near to this, what I will do, I'll go and say lock this position, and now I will move this. Beyond this 2 mm, you will not be able to move this. This is how you can find out the dynamic clearance, and there we can lock the component when you are manipulating the component, that is when you are dragging the component near to another component. So this will make the user to work closely with the assembly to create more accurate results. And we want to understand the different options available in the move component. Let's see in detail. Let's see one more interesting feature in SolidWorks when you are manipulating the component. Now in this assembly, if I drag this wheel, that is if I rotate it, you can see here this bottom component is colliding with this robot, but I don't require this condition. I need if the surface is colliding with other surface, and that component should move, that is it should have the relative motion. For this you need to go to move command. Here we need to go for physical dynamics. Now if you rotate this wheel, you can see the difference here. This is how you can apply the physical dynamic condition, and you can understand the relationship between two assembly, and you can also understand the real-time behavior of an assembly. And this is all about manipulating the component in assembly in different ways. The next topic is creating pattern and creating exploded views. It is very essential for an assembly to show in an exploded view, because without exploded view you cannot detail your assembly in an assembly modeling environment. And apart from this, assembly pattern will reduce the task spent in creating or in positioning the component in multiple locations. And the pattern can be done in three ways. One is linear, and next circular and feature driven pattern. Linear and circular we had discussed in Sketcher part modeling, so that we don't want to discuss more. Let us see how we can do pattern based on the feature. Let's see how we can do this in SolidWorks. At first I would like to show you mirroring the component about and plane. This is the component wall side. I need to mirror about and plane so that I can copy on this side. Now what I will do is I will go to insert. Here we have mirror command. Plane is this is my plane, and the component is this. How many components you need, those many components you can select and go to next. Here you can see the component is located, and you will have the option of defining in different orientations. Which orientation you need, in that orientation you can position the component. And once you defined all this, what you can do is you can go and select done here. Now the component will be located, and this will have a specific information on this same tree also. Like you can see here, mirror component, you have a separate list, and when you save this component will be saved with a specific name. And this is how you can create mirror command. This is how you can create component using mirror component command. And now we are going to see creating an exploded view. Now the whole assembly is done. I need to create an exploded view. You need to go to configuration manager, right click here, and you get new exploded view. And now you will have the advantage of triad. By using this you can explode this. The first one, what I will do is I will make in one orthographic view, and I will select this part. Which part you want to dismantle first? I would like to dismantle the spin. Select this and drag this way. And the next component I would dismantle in this way, this spin in this way. And now I can create, I will remove this component, this direction. So like this you can select the component one by one, and you can drag to the required direction. And once you complete this, you can close this dialog box, and you can animate this whole exploded view. Right click here on this explode view and go to animate collapse, and now you'll be able to see how the assembly is dismantled and once again it is assembled. This is how you can create exploded view, and that exploded view once again you can animate to understand the whole assembly in a better way. Of course, this will make the engineer to understand the assembly, and also he can make the customer to understand his concept and his whole product design by doing this animation also. And that's all about creating exploded view and manipulating it by using animation controller. And this is how we can do mirror, and we can do assembly mirror, and we can do exploded views. And now let's see in SolidWorks how we can create feature pattern. I'll close this and I'll go to the tool head assembly. Here I want to position this grub screw. I'll go and say this and this should be concentric and this fade should be coincident on this one. Now we need to create multiple copies because here we have 5 holes. Now I need to locate on this 5 holes. I'll go and say feature driven component pattern, and here I will select component to pattern, and driving feature is this feature. When I select this, you can see this is the seed feature and we can see the component positioned. If you need, you can skip the instances if you don't require on this hole and click OK here. This is how you can create mirror pattern in SolidWorks assembly environment. Top-down approach. As I said before, we have different design method in assembly modeling. We discussed a small view about top-down approach in the previous session. Now let's see how we can create this top-down approach design method. One is layout sketch we are going to see, and the next one is editing part in the context of an assembly. So what exactly this point will mean? It's very simple. In this assembly environment, I need to edit the part. What I need to do is, you can select this part and go and say edit part. Now you can see you are retrieving the environment of the part, and once you retrieve this, you can see double click the component and you will be able to get the each command and each sketch interface here, and here dynamically you can modify this model. This is what we are calling as editing in the context of an assembly. That is what it is defined here. Editing part in the context of an assembly. You can right click a part and select edit part, or you can choose from the callout, or you can choose from the assembly toolbar. And this is how we are editing the part in the assembly environment if you need any change for the specific part. This is very important, since once you complete the assembly and if you want to change dimension of one single part, you don't want to go to the separate environment and there you don't want to modify it, because you can, if you are doing the modification in the same assembly environment, you will be able to guess and you will be able to assure that size is exactly matching with the related component. Means the shaft diameter is exactly matching with the hole diameter, and this is what we call as top-down approach. And one is editing the part in the context of an assembly, and this approach also we can call it as top-down approach. It is editing the part in the assembly environment. Now let's see about layout sketch. Layout sketch. Layout sketch in SolidWorks is used to represent virtual components. Let's see how we can create this. Go to layout sketch command, and now you can see the plane is shown here. I had created a block, and that block I would like to insert here. I will take this block here and insert here, and next one more block I will keep it here, and one more. Before that, I would like to rotate this in this direction, no, in this direction, and this I will make in this way. Now I would like to retrieve one more block here, this way. Before that, I can mention the angle here, and once it is defined, I will locate here. Once I place this, I would like to make this 2 points should be vertical, that is, this 2 points should be horizontal. Now you can see the movement of this link, and you can also say this to be fixed so that you can understand the link relation between this component. Once you complete this, go to the make from part. I will use on block, and I will select this part, this block, and click OK. And complete this. Now you can see a part is created here. and this square bracket will indicate this is a virtual component, means this part will be saved only in this assembly environment, not as an external file. I'll open this and I'll say sketch and I'll say save and continue, and now I'll edit this part, edit this, save and continue, yes, and now we'll go and save this, save internally, yes, give OK, and now we'll be able to see the environment of part modeling, and say feature, extrude, click OK here. Now you can see part is created here, and this you will not be able to move. Now I want to create one more part on this layout. I'll go to make part from block, I'll use project and I'll select this block, click OK. The same like make part from block, project, select this link, click OK. But this is located in the wrong direction. I will delete this. As of now we will study with this component. I will move this. Now you can see this, you can move it wherever required, and once again you can use assembly constraint to constrain this with this base component, and this component should assemble with this face. Coincident. Remove this, and I want to constrain this face on this one. This is how you can use layout sketches to create virtual components in the assembly environment. So what exactly this virtual component? When you are creating the design in the top-down approach, that is, you have only the rough sketch and you are going to create part, and you are undergoing number of iteration, then definitely this approach will help you to create the model, because the part will be saved internally, not externally. If required, you can make it as an external file. And apart from this, you can draw a 2D sketch in the same environment using sketch tool, and you can assemble the parts. Like if you want to assemble the truck, you can draw the first top view of truck and you can assemble the components on the specific location. And that's all about top-down assembly in SolidWorks. The next topic is creating smart components. Smart components are useful for the user to create the component which is going to be used frequently, and that component will be associated with the components and with the features. Means you can see here an image, and here this plate which is inserted in multiple locations, you can say when it is inserted, I require only one bolt, I don't require this second bolt. And now this plate will be created as a smart component, and when you insert, you can retrieve which bolt you require. Let's see how we can create in SolidWorks. This is the subassembly. I'll go to tools, make smart component. This is the primary component, and these are the two components which I need to insert if required. I'll click OK here and save this, and now I'll go to the main assembly, and here I will retrieve the component. Which component? The plate. We'll go and say part. Here I'll take this plate, click open here, place on this location. Now you can see here you will have a dot, and select this dot, you will be able to see this window. And now this window will help you to understand which component you want to place. You want to place only one bolt, or you want to place this bolt, and click OK here. Now you'll be able to see this component will be associated with this part, and moreover you can insert which component to be located there. And this is very easy for the user to understand which feature, which component should be associated with the other component, so that you can avoid the time spent in making multiple repetitive tasks and also multiple copies. And that's all about creating smart components in SolidWorks. Inserting smart fasteners. In SolidWorks, you have the advantage of inserting the ready-made standard bolts and nuts into your assembly. You have toolbox from where you can retrieve this smart fasteners. And there is one more intelligence in SolidWorks. When you select the hole, based on the hole size, the bolt will be inserted, and also you can populate on all the hole which is there on the pattern. Let's see how we can do this. I'll go to SolidWorks environment. Here I need to insert the bolt on this face, on this hole. I'll go to smart fasteners and I will select this hole and add. Now you can see automatically, based on the hole size, the screw will be added here, and click OK here. And when you want to change this, go to edit fastener and right edit grouping. Here go to series, right click, go to change fastener type. You can choose the various type of fasteners available here based on the standards also. And this is how you can insert smart fasteners in assembly modeling. And once you complete all this, complete the 3 projects given in your SolidWorks reference project workbook. And each assembly has to be completed based on the direction given, and it should be completed within the stipulated duration. And once you complete it, evaluate by going to menu, tools, assembly expert, and study the statistics, and also find out the collision and interference wherever required. I hope definitely this command will help the user to assemble the component as simple as possible. And that's why we are saying focus on design, not on the software. And that's all about assembly modeling in SolidWorks. In this video, you will be watching how SolidWorks assembly environment will be used to assemble components for an assembly. In your SolidWorks project workbook, you have 3 exercises to practice the assembly commands and tools. The first project is ram bottom safety wall. The second project is mission wise. The third is the tool head of a shaper machine. Before we go into all these projects, how we can assemble the whole set of assembly, let us see how the complete project is done in SolidWorks, so that we can assume how exactly each and every component will assemble in different location in different position. In this screen you can see the ram bottom safety wall is assembled, and you can see all the components are exactly assembled as per requirement given in your project book. So here you can see the sectional view, which will make you easy to understand exactly how the different component is assembled. And this sectional view once again will give you an easy idea how the edges or vertex can be selected to assemble 2 components or to make 2 components. And here you can see every parts will be listed with balloon, so that it will be easy to understand exactly which component should be assembled with the other component. And now let's see the different parts available in this environment. Just go to the isometric view, and I will show the animated view, that is unexploded view. I'll click this exploded view. Here I will show you. I will keep in one direction so that it will be easy for me to load. What I will do is one view, I will use space bar to get this dialog box, and I will make front view. Here I have the right side view. Finally, okay, this view is enough for me. It is front view. Front view, now you can notice how each and every component is assembled and dismantled. If you look into this animation, it is not meant for exactly how it should dismantle as like you do in the practical life. But here to understand how each and every component is assembled and how many components are present. For that purpose, I'm just animating and showing you this video. Now let us look into one more point. There is one more assembly animated explorer view, which will give you another view about the different components assembled in this ramp on safety. I can spin this model and I can show you how it is assembled. So here we have pin spring, and apart from that we have this pin, split pin, valve seat, and nuts to lock the components. And this assembly we are going to see how and what are the constraints we can use to assemble this whole environment. To start with, I need to open a new file, new assembly, click OK here. So once you click OK, you will be able to see this left side will have begin assembly. Click here browse, and I will choose my documents from the library. The first base component is body, and click open here. Now before I place this in this graphical window, I can say I don't require all the sketches to be displayed, so I can switch off this display. Now you can see the component will be shown without sketches. And if you look into this video, if you look into this, the first component what we fixed on this ground, it is fully different. You can see I cannot move this using my cursor, and here you can see the prefix with starts with the F. But now with respect to origin, this is not exactly in the center. So what I will do is, for my convenience, I will make this to float, which means it can move anywhere. Now I will retrieve the command using the shortcut S and mate icon, and from here design tree I will choose the origin point of this body from here and here. Now you can notice the 2 points exactly coincided. Now I can say OK and just see the isometric view. The first part is exactly grounded as per requirement. The first component is located, that is fixed. Now we need to assemble the other component on this body. To retrieve the component, we have two methods. One is we had seen we need to retrieve the command insert component from the shortcut, or we can choose from here. Now I will go with this insert component, browse from here, and I'll go to my library parts where it is saved, all seat, click open. Now the part is located here, and this part is not constrained, it doesn't have any condition, so it can freely move in this space. Now this component should be placed on this surface, that is on this slot. Now what I will do is, I will go and choose once again mate, retrieve the command mate to add the mating condition, and here we required this surface and this surface should be concentric. Now you can choose this surface and this surface randomly. Automatically you can see the concentric constraint, that is mating condition, is added, and apart from that the software will show you a callout where it will show you all the possible constraints you can apply for this combination. That is, the two combination is the cylindrical surface of one part and the cylindrical surface of the body. Now my preferred mating condition is concentric, so I will click this concentric and click OK here. Now we locked 1 degrees of freedom, that is this concentric condition. The next what we required is, this has to locate exactly on the top surface. This bottom surface should rotate on this top surface. So I will use, defaultly it is using coincident, so I'll accept this one. The next one is this. You can see here it can rotate easily on this axis, but I don't require this axis should rotate, that is this component should not rotate about this axis. Now for this, what we need to do is we can expand this design tree, and here you can say my front plane, okay, or okay, not body. We can choose either, we can go for first selection of either one. I'll go to select first wall, and here this is the front plane and the assembly front plane, both should be parallel, not coincident, because my requirement was only parallel condition. You can either give parallel or coincident, nothing wrong in it, but here my intention is to give only parallel. So once it is finished, I can click here OK. Now I will cancel this dialog box, and now the two parts is exactly fit in the screen. And now my next component I would like to retrieve here. So what I will do is directly open the this browser, it is Windows Explorer, and from here I will take directly this wall seat. Okay, once you place this wall seat I need to assemble here. So once again, mate, I can choose this and this as the concentric. This surface should be coincident with this surface, and similarly this face is parallel to this face, and here I will choose parallel and click OK here. So once it is done, I can give OK, and we completed the assembly of next component. And now I require another part, that is wall. So once again I will drag this part here, and once the part is dropped here, now we can start applying the mating conditions. The first mating condition is this beveled surface, this conical surface should exactly land on this beveled surface. For this, once again I can go with the approach of using mate, but now what I will do is I will use Alt key, and I will drag the surface over this surface. Okay, now you can see automatically it applies the constraint where exactly the two surface is having this coincident constraint. Click OK. This is one more method of mating the two components smartly using the Alt key in the keyboard. Next component is also, that is in total 3 components we assemble. If we required similar like this component on this side without doing additional work, what I can do is I can right click this component, I can say copy with mates, and directly I'll go and say this is the surface, and now I'll say right click, give OK here. This component is also OK. This is another method of assembling the component using copy with mate. And now we have totally 4 components assembled, and the next component we need to choose from the library. Either I can go with pivot or bend, whatever according to the requirement we can choose and we can assemble. The next set of components will be assembled by dragging the parts into the environment. Now we have body, the remaining parts we required link, lock nut, pin, pivot, shackle, spring we will take it later. Valve seat we assembled, valve we assembled, washer we require. I drag all this component into my environment. This will save some time so that we can concentrate or focus on the design. Here this washer is used for this shackle to support on this face. Means this washer will evenly distribute the pressure when it is applied on this shackle. Let's see how this will be assembled here. I'll go and say mate, this surface, not edge, this surface should sit on the surface. Similarly, this and this surface should coincident. This surface and this surface should coincident. Once the washer is located, we can go and choose this shackle to place here. The top surface should place on the bottom surface. Similarly, this surface should coincident with this surface. Similarly, this surface with this surface. Yes, the shackle has been placed on this washer. So now this washer will help to distribute the load equally on the surface, and also you can avoid too much of pressure exactly on this plate. Now bottom we need to have two nut. We will look into the sheet, which is the first nut to assemble and second nut where it should come. So here you can see the length which is the nut which is having the length which is bigger than, that is we have one nut with minimum length and maximum length. I'll go with nut which is maximum in length, which we call as nut, but which is at the second, which is at the second end, which will lock this, we call as lock nut. It is here. This is what lock nut. Now I'll go and say this surface should be concentric. This surface and this surface is a here. This both should be concentric. Nut has been assembled. The remaining this lock nut, which means this surface and this surface should be concentric. This surface should be assembled. Now we assemble two nuts here. Now the link part should assemble on this face. This is the link which will support the shackle connectivity with the lever, thereby connecting the spring also. Let's see how we can assemble this. This face should coincide on this face. This hole should be concentric with this hole. Yes, and we require another thing. This face should be perpendicular to this. We can use this column and say perpendicular. We require another link on the surface. So instead of retrieving from the library, what I can do is I can go with right click. I can choose copy with mate, and I can say this is the face I want to place, and this is the one more hole which I want to make concentric. You can flip the direction. Finally, this is the face which will define the direction of the connecting link. But here, see that this is not our intention. We had to assemble on this top. So I'll go and choose this concentric face and clear this section, and I'll place it on this surface. We have to once again choose the surface, and now you can see here it is asking for us to define the surface. This surface. Yeah. So when you redefine it, it is located exactly as per our requirement. Now just see in the isometric view how it is assembled. We have another component pivot. We have split plane. This should be assembled here. So I'll move this pin here, split pin near to the assembly. Now we'll start to assemble this. Mate, this part should concentrate with this part. Yes, and this surface should be coincident. once it is done, now we have the provision to place split pin. Split pin is available here. I'll drag this manually where I required this, and I will say exactly this face and this face should coincident, and manually drag this and I will place as per my requirement. But later we can change this as per a requirement using some distance. But here, as far as this is concerned, I am leaving it rough, since we need to evaluate the entire assembly for clash reduction and misalignment everything. So once it is done, click OK here, isometric view. The remaining component we need to place above on this remaining parts. Next, we need to assemble this pivot on this top of this wall sheet. What I will do is the same approach what we did earlier. Mate, this vertex should exactly land on this vertex, and it has 2 degrees of freedom on this side and also this side. This has to be blocked. What I will do is I will select this surface, and this surface should be parallel, and this surface, and I can choose either from here or I can choose from assembly. This plane should be parallel, and click OK here. So once this is done, now we are in position to get the additional component inside. And this is completely, if a component is fully defined, you can see here the component which is fully defined, that is, which doesn't have any degrees of freedom, will not have any prefix. But the component which is having undefined, which means it has some degrees of freedom, will be prefixed with undersign, which means a minus symbol is shown here. You can see here. There is a sign for underdefined component. There is no sign for, there is no prefix letter for this fully defined, and it is not required that every component should be fully defined. It depends on the functionality, it depends on the mechanism, it depends on the requirement. Now I will go and choose the remaining components from my library. Here I required the lever 1, and even after placing this lever we need a spring. So first let us focus on this so that the next component will be easy for us to assemble. Mate, similar approach. This should be concentric on this circle, on this hole, and here instead of understanding exactly this length and this gap, I will go choose directly from the advanced mate. I'll choose width, where we can define this surface and this surface should exactly position between these two surfaces. Now you can see here it is exactly positioned. Now this has to be positioned here. So what I will do is, now we need to assemble exactly up to here so that it should point on this face. So I will choose once again this point, vertex on this vertex. Sorry, not this face, this vertex. Now we need to choose not symmetric, coincident. So once it is done, you can notice how it is aligned. Everything is aligned exactly as per our requirement. The next step is, here this whole set of pin should be assembled. So for this, the same approach, what we can do is, I can select this, I can say copy with mate, and I will choose, this is my concentric surface, this is my face, yes, and finally it requires one more time, that is, this is also required. It is prompting for the cylindrical surface to show. So here I don't have anything, so click as it is OK here. I can see it is not located properly here, so it got it got cancelled. Now once again we'll try with the same copy with mate. I'll go and choose this component, right click, copy with mate. Here this is the component. It has to concentrate with the surface, and I don't require on this side. It is on this side. I require on this side. Select this face, and once we finished, we need to choose the reference for the split pin. But here we don't have split pin. That is why previously we are not able to define all the condition for this. So now what I will do is we cannot use this command at this stage. We need to retry once again the component from the library, but it will be once again using the mouse, moving here and there. To avoid this, what I can do is I can just use Control key, and if I press and drag it, another component will be generated. The component will be copied. Now as usual, I will go and choose mating condition for this, and this should be concentric. Similarly, this face should be exactly on this surface. Correct? Yes. And now the split pin has to be placed here. So once again I'll use another time the control key, and I will say this has to be exactly aligned on this face. Now you can drag this by keeping in one view, so that the aligning will be easy for you. The place in this view. Yes, this is the exact view required. I can now select this edge, and I can say I should place it here. We are placing not exactly, because split pin not required to exactly place there. Just we need to represent the split pin is assembled here. So once it is completed, we required the spring to assemble this lever with this entire setup. So I will go to the documents. Here I have a spring which is done earlier. I retired the spring. The spring has to be aligned. To assemble the spring, we don't have enough reference. So, enough reference, what I mean is enough geometry reference. We can choose only these type of references which cannot be aligned exactly on these two frames. Here what I will do is the spring datum planes, this front plane, and with the assembly front plane I will assemble the first one, and once again I will say this right plane should assemble with this component's right plane. Correct? Yes. And now we can move it roughly as per requirement. I will keep it with one view so that it will be easy for us to do this. I will drag this, I will keep where it is required. Okay. You can see here exactly the whole assembly is finished, and you'll be able to see the RAM button safety wall is assembled using mates, which is available in the this command, that is mate from the command manager. That's all about creating an assembly modeling using graphical user interface of SolidWorks. Once we complete this assembly, let us check the parts list used for this entire assembly. To create a part list in the same environment, go to Insert. Here we have Tables, Bill of Materials, and here you choose OK. And I don't want to go for additional window, the same window I require, so I will choose Existing Annotation View, click OK, and place the box here. If required, you can drag and you can enlarge the size, and you can view this. Other thing, everything you can control from the properties table. But here we need to check whether whatever the components list given in the sheet is matching with this. Now I will place the window on one side and let's see the number of components. Here if you see, I'll just drag this. Description we don't require. Let's check this later. Let's check with the number of parts we used. Body 1, wall sheet 2. Okay, everything almost matches, but apart from one thing, we required this pin and split pin to be 3 numbers. But here if you see, we have only 2 and split pin as 2. So what is missing here is, we need to assemble this link with this pivot using split pin and pin. Now I will drag this component, and here we will use once again mate, select this face, concentric, and these two faces should be coincident. And next we required this split pin to be available here, so I will drag this using once again the control key, and we are going to assemble this. Where is the component? Okay, if not, then I will choose from here, check whether where it is available. I will do one thing, I will delete this and once again retrieve this, so that unnecessary things will not be happening there. So pin is shown here. Even I don't require this table to be shown here, so what I will do is I'll go and delete as of now, and we can generate as per requirement. So I require one more copy. This side I will keep it, and I will say mate, this face should be assembled on this face, and the same thing I can use the orientation plane so that the split pin can be assembled as per a requirement. We'll see in this view. Okay, this view is showing, but the requirement is satisfied. So what I will do is, instead of orienting, I will just select this edge and I will say how it is required, and apart from that I'll do one more constraining which we don't require it, but still I will do it. To align this, I will say this edge and this edge to be parallel. Yeah. So now it is aligned exactly. So once this is completed, now we can produce the bill of material list, and then so one more important thing, we need to check the interference. Interference check we can calculate using this evaluate command manager. From here you can choose interference detection and click here as calculate. If you see, we have about 6 interference we are able to find here. So now your job is to understand where the issue is, what we need to do to avoid this. Now one basic thing I would like to show here. Here you can see the split pin is not properly located, so it is having a slight interference with base link. Now what I will do is I will go and manipulate so that the spring interference will not be shown here. So for this I'll go to mate and say this edge and this edge, not edge, not point, this edge. Once again I will redo this, select this edge and this edge, and I will say parallel and click OK. Now this pin should not have any interference. Let's go and check the interference check. Interference reduction, calculate. Now you can see previously it was I think 6, now we have only 4 interference shown here. And now one more thing what we need to check is the same problem we have here. If we orient the split pin, we will not have interference with this part also. To cancel this, I'll go here near to this component and I will say mate, this edge should exactly parallel to this edge. Correct? Parallel. Click OK here. created 3 pins. Now we'll go and evaluate the interference, calculate. We have only remaining 2 issues we have in this. It is aligning with this. It is we need to move a little bit upside direction. We need to move in this direction. Yes. Anything else? Let's go and check once again interference direction. Okay, this area where it is. Okay, I move a little bit outside. Okay, this way where it is shown. Okay, the same we have in 2 different volume it is showing here. Now I'll go and say a little bit. I need to go inside. Now interference calculate. Yes, it's perfect. Now the entire assembly is finished and there is no interference between the components in the entire assembly. To understand it better, we can even go for section view creation also. We can just show to our students the interference view. Sectional view. I will orient this in front view so that you can see how the entire assembly is done. All these faces, how it got seated, and the assemble of spring. There is one more interesting thing we have here, that is the geometry of the spring. Now everyone need to know how this spring geometry is created. Now I will tell you the steps involved, the commands involved in creating the spring. Let us look into that execution part of the spring creation. Here you can see I had removed the sweep command, and I had shown some of the sketches which is used for creating this entire curve. First, what we need to create is the usual thing using helix and spiral command. You can create this base helix curve, this curve. It is having pitch of 97, and you can see the different parameters entered to create this helix. Constant pitch, start angle, and pitch and height. And start angle, you can see it is given as clockwise 270 degree. Once it is created, the next we need to exactly offset a plane from the bottom to a distance of 127. Right? So this will define the radius height, which exactly should have, you can see here, 30. So this radius of R30 will be drawn on this one in such a way the plane should be on this top surface, which means this is having a total height of 97, and if you are offsetting a plane to 127, so which means you can understand that the distance between these two will be 30. So choosing this plane, that is choosing the front plane, we need to draw this first sketch radius, that is arc, and on this top plane you need to draw another curve like this. Then once you complete these two, what you can do is you can go to curve command, okay, and using the curve command. Now to understand this, what I will do is I will just hide this curve right now so that we can understand this. Now here the curve we need to use composite curve, project curve, and here sketch on sketch. I can choose this curve and this curve. Now you can see a loop is created here, open loop is created here. So once this is created, you can give done, and you can have a curve like this. This is how, with continuation with this spiral curve, we have this. We have this, not a loop, I can say that this is an additional bending curve, conic curve connecting with this helix spiral curve. So similarly you can draw at the bottom and you can get the entire design. Now I will just do undo and I will show you how this entire spring is created. You can see this is the spring created. So once you have these two you will using these two sketches you will get this geometry, that is this geometry's spiral curve. We have here 3D curve connecting with this helix. You will get this, and after that you can draw one more arc. I can just show you with one view. Just go and keep it at one view. Here you can see this. It doesn't require any 3D arc. It is a normal arc you can draw here. Similarly on the bottom face you draw another arc and the entire thing will be connected, and once you finish this you draw a circle on this end of the curve, and whole curve is connected using a command called as composite curve. So once this composite curve will act as a one single profile, and the sweep command you will select the profile. Here you can see here we have one profile of radius approximately I think 30 mm, not 30 mm, but I'll show that using composite. This composite curve which joins all the curve is selected as a profile. It is path. This composite curve is path and this is profile, and the dimension given for the sketch is, for the circle is 6 mm, correct? 9 mm. This is how the spring is created. Let us see how ram bottom body is created. Here remaining whatever the commands you see here is same, but we have one thing we need to clarify how this centerline parameter is used in loft command. So in the loft command we created the first circle, second circle, third, fourth. Using different datum plane we created this, and using the centerline parameter we had joined this, and ultimately we are able to create this loft geometry. One by one we start creating this, and you can see the end result, how an entire body is created. So this will give you a clear idea about the assembly procedure for ram bottom safety wall. Now the next we are going to see the machine wise assembly. Machine wise is a work holding device. As we know that it is used in shop floor in most of the machines like planner, shaping, drilling machines, especially to hold the job or the work. In this project, in this assembly project, you are supposed to use limit made between movable jaw and vice body, and also you are supposed to apply screw made between screw rod and movable jaw. Let us see how we can assemble this movable jaw in the assembly environment. Now I have opened a file and given a name as assembly project 2, and I saved it. Now first I input the body twice, and as you know that the first when you input the component it will be grounded default in some location. To remove this I'll go and say right click and float, and now I'll go and say mate. The mate I will say this origin, body origin, and the assembly origin should be aligned. So once it is aligned I will go for the next assembly of components. Click OK. Now the next component to retrieve, I will go to the documents and I will take all the parts which is available here by dragging and dropping in the environment. So it will be easy for me to assemble the component. all the components are there. Nearly we have 11 components in this environment, including the first component. Now we are going to assemble the components one by one using the mates available here. Mates, it doesn't mean like only standard mates. We can use even mechanical mates. We can even use screw mate. It is advanced mate also. The first part. Now I want to assemble this movable jaw. The first base part is here. So on that base part I am going to assemble this movable jaw. And next what I am going to do is I want to exactly align this. So I will use width. These two surfaces should exactly align between these two surfaces. So when I align these two surfaces, you can see it will be positioned in the hood of this surface. Now it is free to move here. Later we are going to apply the limiting condition for this movable jaw to move on this guideway. The next component is jaw. This jaw has to be placed here. So I will use this hole, and this hole should be concentric. Okay, we need to apply concentric. It was defaultly selected in other advanced mate. Select these two holes using concentric. And now what I will do is I will flip this and click OK here. Similarly this and this should be aligned, and now these two faces should be exactly coincident. Done. Now you can see here the jaw is exactly assembled on this face. The next one is we need one more jaw on this face. So we'll use Ctrl key, drag to place another one more component. Now I will use mate, this face, reverse direction, done. And now this hole and this hole has to be aligned concentrically, and I'll just drag this. It should be easy for me to position this concentric. Yes. So once this is completed, we need to use screws to assemble this. So I will choose this surface, revolve surface, and here there is one more revolve surface, and flip this. I can see completely the screw is inside. Once this is done, the next step is we need to use the screw in all three locations. We cannot go and retry every time. So what I will do is, as you know that we did this command in previous assembly also, copy with mate. Just go here, select this face, right click, spin the model, go near to this, select this face, right click. Similarly here, select the face, right click. Simple. We placed 4 screws here. Now just use Ctrl S to save the program. Now we are in a position to assemble the remaining components. Now I require this handle, the handlebar. This is not handlebar, this is a screw rod. I'll say this and this should be concentric to change the direction of this, and I'll place roughly here. Later I'll apply the screw mate for this. Applied it. I will say this face and this face should be coincident. Okay. Yeah. And now similarly what we did previously, the nut has to be assembled. This nut has to be assembled first, and we need to say exactly. See the wireframe mode because the nut is inside here. So what I will do is I will just drag this component outside, and I will see in the shaded mode. Now I will say this face and this face should coincident. Correct? It should be inside face. So what I will do is I will remove this face and I will say this face, inside face. this face and this face should coincident. Click and accept it. And similarly, now we have Workbench. Select this face, cylindrical face, and this cylindrical face. It came here. Select this face and this face. I can check the sheet what we have. Open this. I can see here. This is not giving us a clear idea. I'll go and see the other details given in the another sheet. See, here you can see, okay, the nut is not that way, it should be assembled in this end, and we need to use a washer also. We need to do some changes. So what I will do is, I'll go and remove the constraints mates given for this nut. The nut, we can see it is highlighting here. Using control key, just selecting it up to here, delete. Now I need to move this nut, whatever it is inside here. Just select this exactly, this edge, and we need to move this one also. Now I can just see in the shaded mode. Where is this washer here? Yeah, this washer has to be assembled. First I will say this surface and this surface should be concentric, and it is on the side. So what I will do is, we will go and see in the wireframe mode, and I will just see here it is there on the side, and it is easy for us to understand this surface and this surface should be coincident. And now you can see this and this. See, we had assembled the major portions. Now we have remaining this handle. Let's see how we can do this remaining portion of it. The remaining components what we have is clamping plate, handle cap. We need to assemble all these three components. Now the first thing is, this movable jaw has to be clamped at the bottom. I'll go and choose mating condition. This surface and this surface should coincident. Correct. And these two holes should align. These two holes. Okay. Here this, let's see this hole to be aligned. So now this movable jaw, the under clamping plate is aligned. Next, this should exactly align on this cylindrical face. Now this is free to move on this one. Now I need to say the condition for this. For this, it is advisable to take the symmetric mate and say that this surface and this bottom surface should aligned, should be symmetric with this plane. I think front plane, no, I need to go to screw rod. The screw rod, we can see a plane, front plane. It is defined, and click OK here. Now if you look into this screw rod, if you rotate this, you can see this handle will not move outside. It will be symmetrically aligned between the center of this screw rod, this handle. And now we can use once again mate and say that this face should assemble on the cylindrical face and these two should exactly align. Flip this, yes, and need on other side also. To make on other side, you know that we can use copy with mate, and I will say this is what we required, and the surface is this one. Now we got it. Similarly, if you look into, we need we had messed up this point. we had missed this step. We need additional screw on this area, so I'll go and check, copy with mate, and I will say in this bottom surface, I'll remove this. I will say once again this component screw, and here we'll say exactly the surface, right click, the surface, right click. Now if you see, almost we're done with this, but now the condition is we need to apply screw mate between this spindle, and this should have limit mate. So for this, go to mate. First I will use from the advanced mate, limit mate, and here I will say this face and this face should have limit mate. And here, okay, it's showing some warning message. What it says, these two face should have here. Okay, let's check here what is exactly happening. Now first I will check this is able to move. Yes. Then now we can apply this. Go to mate, advanced mate, limit mate, two surfaces, this surface and this surface. The component may not move, and if is not correct distance, actual distance is 90.3, desired is 1 mm. Okay, it is showing some warning message here. The maximum distance I will apply here as 90, and here I apply here as 50, and minimum distance is 1 mm. I'll click OK here. Done. Now if I move this, you can see here I can move up to here. After this I cannot move because it maintains a distance of 1 mm clearance. Similarly, if I move back side, you can see here beyond this I cannot move it because I defined maximum distance as 90 mm. Now this relation will be driven by screw mate. Go to mate, and from here mechanical mate, choose screw, and say that this face, cylindrical face, and inside there is a one more cylindrical face. We need to choose by using right click, select other, and I can choose from this list. Where is that? This area, correct. Now I will apply distance per revolution as 5. Now click OK here. Now if I rotate this handle, you can see how it rotates. This handle has to be rotated. I will just go and move this slide so that you can see how it rotates. Right? Rotation. Just okay, I will keep it as one view, and I can rotate this. Use say front view. This view. Okay. This view I will make it as wireframe. Rotate in this direction. Or still, what I will do is see this shaded view by using this edge. You can see here when you rotate this, you will be able to see once you rotate one revolution, 5 mm of jaw will be moved in a linear direction, but when you rotate this will not go beyond 90 mm because we are given the maximum distance as 90 mm as a maximum limit mate and 1 mm as the minimum clearance. Okay, so now this is what the advantage you have with SolidWorks when you are using advanced mate and mechanical mate. And now let's see how we can change the display and how we can make exploded views from this assembly. Now let us see how we can dismantle the assembly and how to change the display style of each component so that it will be easy for us to understand the components which is inside the component. Means screw which is inside the body. If you want to notice, we want to change this as wireframe. I can do like this by right clicking on the component inside it is able to see clearly. Now once again I don't require this. I'll go and say component display shaded with edges. So once it is completed, now let's see how we can display. This is the feature manager design tree, and here we have another tab called as configuration manager. Choose this. In the configuration manager, you need to right click on this default assembly project 2 and click new exploded view. To dismantle the parts exactly as per requirement, I will place it in the top. Now I will choose the component one by one by using Ctrl key if I want to move the same two components at same time. Two components I had dismantled, and the next step is I would like to dismantle all these three components. Now choose this and then move side. Similarly, I would like to dismantle the other components. I will go and choose in this view, front view, and I will say this component, this one. Place in the front view, this component. You can see how this component is dismantled. So now once this is completed, you can see whatever the steps you had performed here, everything will be saved under this exploded step 1, step 2 and step 3. And apart from that, we have the advantage of giving exact offset distance for the exploded parts. It is the part which you need to move. For instance, I will take this screw and this screw, and I can say which direction we required. Direction, I can choose X direction. Now X is the position. Now I will say the distance is 30 mm, and now you can see here direction is going in this way. I will flip the direction. Now once we selected, you can see here we have screw and we have jaw, and still if you want to add, we can choose one more component here. Hit apply. Now you can see all the components, all the selected components is moved in the required direction. Also you can say auto space components of the drag, which will ensure the equal distance between the components. So once this is done, you can click OK here and click save, so that we don't have the issue of having unsaved document. Okay, now we completed this. Now what I can do is I can go and say right click, animate collapse. Now you can see here we have this animation controller, and in this controller you will be able to give the speed of the component by either giving slow play or faster play. Accordingly, you can show the assemble and dismantling component of the entire assembly. And it is also possible to save as a separate movie of this entire animation sequence shown here. So once it is completed, I can stop this and once again close, right click, and you say if you require, you can leave as it is, or you can say animate explode, or you can leave as it is. Now the explode view is not active. You can double click and you can make it as active, or you can make an explode. And you can make it as a default assembly view by right clicking and say collapse, explode, right click, collapse. Now this is one way of doing the dismantling of the components once it is assembled. There is a one more requirement we have. We have a confusion once we assemble everything. The parts whichever we want to see inside is in proper location or not. One way we will find out, we'll go to interference reduction, and here we'll calculate this. So here there is no interference, but still I would like to see exactly how the components all assembled in this machine. Now this is only 11 parts, but if you consider the assembly having more than 100 or 50 parts, definitely we require to analyze. So for this, what we can do is we need to have different display. What we can do is we can say display state we have. We want to say add display state, and we need to double click this display state to, and which component you require to make it as an transparent. You can select this component display. Here you can see shaded with ranges. You can say and similarly I can say this should be of shade with edges, but I want to make it as a transparent, so here I can say transparent. And once you complete this, you can see this is display state 2 and display state 1. If you double click, you can see the display of the assembly. This is how you can make different type of display state, which will easy for you to understand and also easy to explain to the students with respect to the components, how it got position in the entire assembly. This is about assembly of it machine wise with exploded view and controlling the display state. The next assembly is tool head of shaping machine. This is the worksheet given in your project workbook, which shows the dismantling of all the components with part list and also ballooning. Nearly we have 19 components in this assembly. In this assembly we are going to do the component made in a different way, which means we are going to create sub-assemblies and then we are going to assemble the components. So we have 2-3 sub-assemblies. From there we are going to assemble in one single component. I can show you the tool head assembly, which is done already, to have a view on this, so that it will be easy for you to understand how the entire assembly will be finished. In this view you can see we have the first component as back plate. The next we have this vertical slide. To assemble this vertical slide we have one adjustable strip, and this strip will be fastened using this screws. And after that we will create an sub-assembly for this entire handle, and then handlebar, screw rod. Using these components we will form a separate sub-assembly, and we are going to create this front swivel plate as a separate sub-assembly. To have a look on into this, you can see here this is the plan we are going to have for doing this assembly. We are going to create a sub-assembly using these components for the stop components plus the screw rod. And second, we are going to create a swivel plate. This front area you can see these components. Using these components we are going to make in one more sub-assembly. So with this we will create separate sub-assemblies. That sub-assembly will be used in a new assembly environment to form the final assembly of tool head. Let's see how we can create one by one using assembly environment of SolidWorks. The first component is back plate. We can check with the details given in the sheet, and then you can retrieve the part. Here the first part is back plate, correct? Yes. So to retrieve the component, as you know that I can go to insert component, browse here from my documents where I saved it, and choose from here back plate, open and place it here. I don't require this to be grounded as in default position, so I will use mate and I will say the origin of backplate and the origin of assembly should coincident. Click OK. So once you do this, the next what we need to assemble is the vertical slide. So to retrieve vertical slide, I'll go to the shortcut, or I can choose directly from the file explorer. Vertical bar. Here is the vertical bar. No, it is vertical slide. So vertical slide component. Minimize this. I need to make sure that these two should assemble exactly. Should mate. Mate. This surface should mate. Okay. And this surface and this surface should coincident. Okay. Now I'm going to leave this vertical slide to move along this back plate. And I'm not going to constrain this degrees of freedom because I don't require it. If you require it, you can make it as fully defined by giving a distance between this face and this bottom face. It may be with respect to datum plane also. Now once I complete this, I'll save this assembly environment. Now once I save this, I would like to open a new assembly environment where I'm going to do the sub-assembly of the next component. I said this rear assembly, which is the back component what you see in the tool. First, browse the first component as screw rod. Before we open this, let us check the list what we have prepared. Here I have given screw rod, spacer, handlebar, round key, nut, handle. To choose this, what I will do is I'm not going to go with this one. I will cancel this and I will going to directly drag and place in the environment. It should be easy for me to retrieve the components. One is screw rod and spacer bar, spacer bush, and then handlebar, and then round key, and then nut M10 and nut M10 and handle. So now I will minimize this. You can directly drag all this components. Now I can assemble this component one by one. We have the screw rod. So now the nut I will float and I will say this screw rod should be exactly aligned with the assembly origin. Screw rod. Before this, you can even reorder this as per requirement if necessary. But here my requirement should be the screw rod should be the first component. So I will choose this origin of screw rod and assembly origin to coincident. And once it is done, now we'll start assembling the other component. Now we'll see this bush and this surface should coincident. To lock this condition, select this face and this face should meet. And once again the nut and this nut has to place on this face. Before assembling the nut, what I will do is I will place this handlebar on this area. Before that, let's see how this sub-assembly is done in the sample what I did here. You can see here the space which is exactly on this face, not on this face. So let us see. First I will hide this and I will just check how it is assembled. Here you can see there is a distance which is needed to calculate. So what I will do is just calculate and accordingly I can enter the values to assemble this. Make this to be shader, evaluate distance, measure from this face to spacer push, and here we had given constraint native condition as coincident with this, and I will say mate move this component to some distance randomly. I will say this, and this face should maintain a distance of 25 mm and click OK. So once it is done, the next example, the next part we will assemble here. You can select these two faces and say this has to assemble like this. And apart from that, we need to say this face should coincide so that it exactly fit here. So the next one is we need to lock this degrees of freedom. So what I will do is I will say this edge should exactly should have coincident condition. Okay. You can see we have done with this. We have this round net, round key assemble. So what I will do is select this face without exiting the command and select this face and this face. But here you can see we have a difference between the height of this handlebar and we have a distance between the height between this face and this face is different. So let us look at this analysis later. Now let us assemble this round key here. Select this assemble. So select this radical faces, and now this key is available here. I'll go and see the wireframe mode, and I'll just drag this and I'll place it roughly over here. Later we look into this issue what we have with this difference in the height. Now this handle has to place on this one. Go to mate, select this face and this face, yes, okay, and this bottom face should exactly align on this top face. Okay, so now we had completed, not fully but partially we completed. Let us go and check the interference reduction so that we'll be able to analyze whether this is properly assembled. So I will save this as a sub-assembly component here and make it as rear assembly. You can just enter your name of your sub-assembly parts. Once it is saved, now let us look into the height difference between these two faces. We have a concern in this height difference. So we need to do is we need to do the change in the height of this revolve feature. So what I will do is I will double click this area, which means now you are editing the screw rod directly in the assembly environment. Even you don't want to open the part separately. You can double click this dimension and I will say it's 26. Click OK and choose Ctrl B. It will be updated. You can also open the part separately and you can view the changes updated here automatically. You can see dimension is 26. So once I complete this, now I am able to assemble this rod, assemble this round key. Double click this and notice it is only 10 mm. I need to convert this 10 into 12 mm. Now it's ready to assemble. I'll go and say mate. This face should exactly mate exactly with respect to this face. Now we had exactly assembled this round key. The nut has to be placed on this face. Concentric, move along this axis and say this face and this face should exactly coincide. To remove this point, this face and this face. Okay, done. And just see the isometric view. Save this part and close this. Now we are getting into the next sub-assembly creation. what we need to do is we need to check what are the components we need to go do for the next sub-assembly. We want to do this swivel plate assembly. Let's see how we can create one by one in this assembly environment. So when you do sub-assembly, it will reduce the confusion in doing the entire assembly with keeping all the parts, and also regeneration time can be reduced. Now, what are the parts we require? The first component is swivel plate. The second, we need to place this screw swivel plate to locate on this face, and washer, clamping screw, drag plate, pivot pin, and tool holder, and before that we need to place washer. And after that, tool fixing screw. These are the things we want to assemble. Let's see how we can do this swivel plate sub-assembly. We are in now new assembly environment of SolidWorks. As usual, I go and retrieve the parts from this documents. As usual, I know that this will take some time. So what I will do is I will directly drag the parts here. Let us see what are the components we require. Washer. So I think this washer is different and this is different. Let's see, we will open and check size difference. Washer. Then we required clamping screw, swivel plate, screw pin, drag plate, and then pivot pin. Where is the pivot pin? Here. Pivot pin, and then tool holder, then again washer, right? And then we have tool fixing screw. Tool fixing screw I will take it later. As of now, once again deselected. So what I will do is, once again I will choose from, I'm seeing from this part list, so it will be easy for me. Once again, I will take swivel plate, and then swivel pin, washer, and then clamping screw. So first we will retrieve this into the graphical environment and assemble this. Then we will go for the another set of components. So here the first thing here, this is clamping screw is bolted. This is grounded. I required this to be the first part, so we'll make the swivel to come on the first corner. Now we go to mate and say the origin of swivel plate and the origin of assembly should coincide. I'll just drag this component one by one so that the assembly will become easy for me. Here if you see this clamping screw has to be visible inside, and see this and this surface should be concentrated, and this face should exactly sit on this face. So let's say flip. Okay. Once I do this, now we required the washer to be here, and we can place this component. This clamping screw we can place, but this washer I don't think for the same size. So what I will do is I will use another washer from here. I think this should be the exact size what we require. Or we can even measure using a ball weight. Measure. Diameter of this one is 16. Diameter of this one is 16. So right, this is the washer which we require here. So we do first mate. You see this surface and this surface. Flip the direction. And I say concentric. Okay. Now I just drag this. But if I make concentric, it behaves in a different way. So what I will do is I will remove this concentric, and I will apply a different cuts with this. I will apply a tangent mate here. Delete. I will apply tangent mate, this face and this face, tangent mate, and let us look into one view and we will decide whether it is assembled exactly or not. This is the front view. Okay, click done here. Now I'll move this part. You can see here as per requirement is moving. If required, you can just place in the middle by aligning with the data plane. Now I'll say this face and this face should coincide. Okay, and now we don't require these two faces to assemble, correct? So what we'll do is I will go and remove this coincident and I will say drag place anywhere. But first we'll make sure that this washer should assemble here. This face and this face should coincide, and this face and this face should coincide. And now I can say these two faces should have the coincident. And now if I place in the front view and if I drag this, you can see two components will move as one single. Okay, now we have completed partial set of components. Next we need to assemble here the swivel plate one by one. Let's go to the once again the parts what we have in the library, and here I will say which one we require is drag plate, correct? Yes, drag plate, and we require washer as a big there. So drag plate, and then pivot pin, okay, pivot pin, and then tool holder, and then we have one washer here, tool fixing screw, right? Tool fixing screw. This is tool fixing screw here. Okay, and these are the components I require to place in the graphical user interface. Place this. Everything is available in the environment. You can assemble this. This component should locate on this. Let's see whether this face or this face should come on front. I will go to the part which is assembled here. Let's see the sectional view of this so that we can have a clear idea about how we need to assemble this. Zoom here, click OK. I can see here, I hope we had assembled this clamping screw on this face on that part. So we need to relocate it. This is the face, it should be on the back side. Change this first. Go to the editing condition, and here I will say edit, and I don't require that face, I require this face. So first we'll assemble this, then we redefine it. Mate, this face and this face should concentrate. This face should exactly assemble on that face. Which face? This face. Make sure that it should assemble on this face. So what I will do is I will remove this concentric condition, not this one, coincident. The condition I need to remove. Say remove this. Now the screw is able to move in this direction. See now, let's see the sectional view so that it will be easy for us to assemble exactly. Click OK here. Assemble on this face, correct? Let's move and see how right? Face I want to this area. Yeah, I think we had done quite correct position of the screw. So once again I will do that. Go and say mate the surface. The surface should mate. This one. This face, this face. Okay. Now let's free to rotate. This is not our intention to propagate something. So once this is completed, the next part is we need to place this key on this assemble this component. So let's see first in the wireframe mode how the tapper key is aligned here. You can see here tapper key starts from here. Okay, correctly I think it is arranged. Let's see in one view and we can design whether okay correct. This runs in the proper way. Now I can say mate this face and this inside face. Correct. see in the shaded mode, and we can leave as it is. How it is positioned here, we can leave as it is. We don't require any other degrees of freedom for that property. And now next position is we need to place this washer. Select this face and this face, right? And this should be concentric. You can check with the sheet which is given here. This is not the seventh one. Here you can see. Correct. Here we have washer. Then we need to position this. So to position this, what we need to do is we will check with the assembly what we did here, so that it will be easy for us to assume it. You can see here this holder is exactly located from this side. So let's go here. We also make it as a sectional view, so it will be easy for us to assemble this component. Okay, here and mate this face, this inside face should mate, right? And this too should be concentric. And click OK here. See with our sectional view. Now once again this clamping screw should be concentric. Direction. Click OK. And distance can be given manually as per our requirement. So there is space for aligning the tool. Click OK here. See the result. Now we can say evaluate. There is one interference available here. So what we will do is we can go and say the distance should be reduced. So what I will do is we have given alignment, okay? So we say not coincident. We need some distance. Here 2 mm is good. Yes, 2 mm is okay. Click OK here. And evaluate interference reduction. Calculate. Yes. So entire assembly is done. Save this. Now next session we are going to see how to assemble completed two sub-assembly in one single environment, and will complete the tool head of a shaping machine. Now we require the adjustable strip and the fastening screw. I'll go and choose from here, from the browser. I'll drag and place it over here, and now I'll say this surface and this surface is coincident. Okay, we need to apply the mating condition and say this surface and this surface should mate, and this surface and this surface should align, this and this inside face. Correct. And these two faces should be exactly aligned. Correct. And now we require the screws to place inside. We'll go to we have the components from here, screw, grub screw, and we'll place it here. This has to be assembled all these holes, mate, select this face and this face, and then this and this face should coincident. As you know that I want to place similar screw on all these holes, what I will do is I will right click and I will say copy with mate, which will make my job easier. Select this face, so you can remove this, and then I will say once again this part, and here I need to choose the place, and I will say this face, and this is the face. Now you can see, right click, and once again this face and this face, right click, similarly here, and last this face. Complete. So this finishes the adjustable strip and this fastening screw. Now the remaining thing is we have the swivel plate assembly. I'll go and retrieve from here, browse. Here I have saved my swivel plate assembly. We have here. I'll open here and I'll locate this. Once I locate here, now I'll start to assemble this. Mate. This face should mate on this face, correct, and exactly this should align on this face. We need to make sure that these two faces should align exactly. But you can see there is a warning message which shows it's over constraint. So what I will do is I will go and say the mate what we applied here, that is this face I will remove, and I will say I would like to mate this face. Okay, it is aligned. When I removed it, it is automatically resolved. And we need to adjust this one. It is we need to check whether this two hole is aligned exactly or not. What I will do is I will go and check with this sectional view. I need to change the view this direction, and here I can check whether it is properly aligned or not. Here you can see it is aligned properly. Click OK here. Let's see. Yes, so we are aligned it exactly as per requirement, and we are also able to see the interference is there or not. So we go to evaluate interference reduction, calculate. So now we have two interference which is shown here. One is this area, and one more is okay, and there is one more area where it shows interference. So what we will do is we need to check the misalignment what has happened with these two cases. Let's see how we can sort out the interference by adjusting the constraints, by applying the proper mating conditions with the geometry dimensions. Let's see how we can sort out. It is found that we have two interference, one at the bottom, one at the top. So let's see how we can sort out. To do this, we need to have one more condition to mate these two surfaces so that we can avoid these condition, mating interference condition. So select this face, and this face should concentric. Now if I go and calculate the interference, the bottom issue will be solved. Only we need to solve this clamping sleeve area. So what I will do is I will open this sub-assembly, and there I will change the modification. Go to an assembly. Here this part is right now able to freely rotate on this face. So this I need to lock. Let's go and say mate. I want to mate this clamping screw in the middle. So what I will do is this front plane of the clamping screw should coincide with the front plane or the right plane of the assembly. Okay, now let's say this is assembled properly, that is mated properly. Now I'll save this. Now let's go to the assembly. Here we'll update this using Ctrl B shortcut. Now I'll go and say evaluate interference, calculate. Now you can see there is no interference. Now the complete assembly is ready. There is one more remaining sub-assembly we need to do. It is this area, that is this back plate assembly. Let's go and see. Let's go and see how we can assemble this. Select insert component, browse, and where is the rear assembly? We have here rear assembly part. Open this, place it inside. Say concentric. These two face, yes, and drag randomly. Because I didn't constrain this vertical slide, so it is moving on its own. So what I will do is I will just move this to some distance, and now I will say this face and this face should coincide. So it should coincide. Now you can leave as it is, or if you want to move this component, or if you want to keep it specifically in any direction rotation, you can place the handlebar, everything as per requirement. Okay, so this is how we can do the assembly parts, which is having 19 component. By doing sub-assembly, and we can complete assembly as also. And we had found that there is no interference in the entire assembly. As soon as this is completed, we can also make this part to be transparent so that it will be easy for us to understand exactly how each and every component is assembled. We can go for wireframe, or we can say it as transparent also. Apart from that, you know that we can even apply colors so that we can differentiate the part. Now what I will do is I will make it with shaded with edges. Now here we can go and change the colors. Backplate, which color you require, you can choose. So when you apply color, it will help us to identify the component exactly how we require this. So I'll pin this, I'll say OK, and now the second component is applied to the component number, applied to the part document only. So I'll select this face, this color will be applied, I'll choose OK, and similarly we can apply the color for each and every component so that we can differentiate the components easily. Apply this component, clamping screw, and this handle, finally you can leave it as it is. Click OK, cancel this. Alright, just see the preview, and you can go and take some snapshot out of this and you can publish. That's all about making the tool head assembly of a shaping machine. To assist you to create the vertical slide of tool head, I will be showing you the steps involved in creating the fluent. So first, the basic command what we use to create this vertical slide is extrude, where you can see the sketches is fully defined. Just this sketch is fully defined. The next step what we need to do is we need to create a cut. The cut is created using this. In all this dimension whichever I am showing here, it is given in your project notebook. You can refer that, you can create similar approach of creating this vertical slide. So once you complete this, go and create a plane of distance 25 mm offset from this base surface, from this surface. Now you need to create another extruded face using this sketch. You can see the sketch creation. We have an arc of radius 150 and another distance 35 mm is offsetted from this bottom face. So using that, you are applying a distance of 25 mm as extrude depth. Correct? So this has to be created using the different end condition in the extrude. So we will create this sketch and we will use up to surface and we will extrude up till this surface. Correct? Okay. The next step after creating this, we need to create another feature here, and I'll just show you the sketch what we used here. So radius 15, diameter 16 for the hole, and the offset distance is 36 mm. So once I complete, I'll go and create another two sketches for the guide way. Just keep it in the top view, and so that it will be easy for you to understand. Here you can see we have created a sketch. Just double click this, or I can enter to the assembly sketch environment. I can show you we have 25 degrees here, another 25 degrees inside, and we have 40 mm, 35 mm, and I can notice how this sketch is created with fully defined. So once I define this, you can go and create another extrude cut, where it is here. You can see this is the extrude cut what we require to create the base geometry what we require. So I'll just show you the exact dimension what I used here. You can see here. So using the existing sketch, I had removed this unnecessary area of what we have unnecessary material. Once I complete this, the next step is here you can see a square cut, square, I think it's a rectangle. So rectangle of length 20, and this edge is referred with the top features edge, and it is having an extrude cut of length 3 mm. So once I complete this, I'll go for another hole creation, and we did a linear pattern. So linear pattern, I given the direction as this edge. This edge is used as a direction for making the whole number of instances. So once we complete, as you know that the fillet should be given at last. So here you can see the fillet is applied on this face, and finally we have done an extrude cut on this face. This is how we can complete the vertical slide of the head. Let's see the creation of backplate. Backplate creation. Here I would like to show you with using the viewer. Here is a part viewer. Rewind this. Now I'll play one by one. The first component, you can see the extrude. Second, you can see another extrude. Third, we have the back geometry, which is having an angular dimension. Next, we have one more plane and cut creation. Here you can see another hole creation. Next, we have this plate and space. This line shows. Next, you can see another vertical slide. This vertical cut has been created in this area. You can see a plane, data plane, another cut, finally a hole. So this completes